Okay, let's zero in on something truly formidable today.
I think formidable is the right word.
We're diving into a plant that sounds like it was engineered in a lab. It's a member of the common carrot family,
Right.
but it's reported to cause temporary or even permanent blindness. This is one plant you absolutely do not want to tangle with. It is massive, tenacious, and seriously toxic.
Today, we are focusing our deep dive on a botanical titan, Herculeum montagasianum.
Which is more commonly known as giant hogweed.
Exactly. And what's immediately fascinating, and frankly a bit of a warning sign, is that its scientific name literally references its demigod-like size and strength. We're talking about a Herculean effort of growth packed into a single plant.
And that demigod status is absolutely earned. So for you, the listener, our mission is to unpack the plant's surprising characteristics, understand the exact mechanism of its toxicity, and trace why this invasive species has become such a botanical final boss in ecosystems worldwide.
It's a story of beauty, betrayal, and just brute persistence.
And we have to hit the scale of this thing right up front.
We do. The sources are clear. This plant can reach staggering heights of up to 5 meters.
5 meters. To put that in perspective for everyone, that's as tall as a full-grown giraffe.
It is.
When you think about this being an herbaceous flowering plant,
Yeah.
no woody stem like a tree, the idea that it can get that big is just, it's wild. It completely dominates its environment.
So let's start with that physical structure.
Yeah, let's.
It is, fittingly, named after Hercules himself, reflecting that size. And it's supported by a single, hollow stem that isn't just tall, it's thick. At the base, it can be 6 inches wide.
6 inches. For one stem, that's like the diameter of a small frisbee. It's an incredible piece of engineering, really. Just a giant reinforced drinking straw holding itself up.
It is. And it's vital to contextualize where it sits in the plant kingdom.
Yeah.
Because that 6-inch stem belongs to the massive and generally pretty aromatic Apiaceae family.
The carrot family.
The carrot family. A huge group, about 3,700 species. And it contains some of the most common and, beloved vegetables and spices in the world.
And that's the bizarre contradiction here, isn't it? Many of its relatives are sitting in your spice rack or your refrigerator right now.
Right.
We're talking high-profile members like celery, carrots, dill, fennel, coriander, cumin.
It sounds like a botanical family reunion gone horribly, horribly wrong.
It does.
And, just like any large family, the Apiaceae family also has a dark side.
Mm-hmm.
The sources call it that because it includes famously poisonous species like poison hemlock.
The plant that killed Socrates.
The very same, which contains lethal neurotoxins.
Yeah.
And then you have the phototoxic members, which is where the hogweed resides. This family really runs the gamut from dinner staple to, immediate peril.
Let's shift our focus to that crucial next piece, the toxicity. This is where giant hogweed goes from just an impressive specimen to a real biological threat.
Mm.
It's not a classic contact poison. It's more of a double whammy. The mechanism relies on something called phototoxicity.
That's right. The plant sap contains these chemicals called furocoumarins. And when these chemicals get on your skin and are then exposed to UV light, so sunlight, they activate. They effectively turn your own skin cells into these hyperreactive solar panels.
One of our sources described this as turning the victim into an itchier version of Dracula.
That's a good way to put it.
Because the reaction is so intensely sun-dependent, the sap plus the sun triggers a severe condition called photodermatitis. But can you break down what those furocoumarins are actually doing on a biological level?
Sure. So when they're activated by UV light, the furocoumarins cause a chemical reaction that damages the DNA and the cell membranes of your skin cells. So you should think of it less like a typical chemical burn and more like a massive localized sunburn that's been amplified thousands of times over.
So the cells just die off.
They die off in large sheets, which results in severe inflammation and blistering.
And this isn't a minor rash we're talking about. What's the timeline and the severity here, especially when it comes to permanent damage?
Well, the reaction usually begins within 24 to 48 hours.
Yeah.
The affected area breaks out in these massive, painful, weepy rashes and blisters that can swell to the size of lemons.
Wow.
And because the damage is so severe, it can often be classified as a second or even a third-degree burn.
Second and third-degree burns from just touching a plant. That's astonishing.
And this is where the long-term impact becomes critical. These injuries don't just cause permanent scar tissue, they also frequently result in severe hyperpigmentation.
So permanent skin discoloration.
Permanent discoloration long after the initial injury is healed. The skin can remain sensitive and discolored for years. sometimes for life.
That's a serious long-term consequence. Is the sap always that dangerous?
It's most potent when the plant is actively flowering, but the recommendation from all sources is to just avoid this plant anytime. Even dormant, it poses a risk.
Mhm.
And we really can't stress this enough. The most extreme risk is to the eyes.
Right.
If that phototoxic sap gets into your eyes, the consequences can range from severe irritation to partial or even permanent blindness.
So for you listening, if you think you've touched this plant, the immediate action is critical. You need to keep that skin completely out of the sun and wash it thoroughly with soap and water as soon as you possibly can.
Absolutely. Sunlight is the catalyst, so eliminating UV exposure immediately is your best first defense.
Okay, let's shift gears from the danger to the plant strategy. How does a plant that looks like a monster movie prop manage to conquer territory so patiently?
It relies on a very long-term strategy, and that's dictated by its unique life cycle. Giant hogweed is what we call a monocarpic perennial.
Monocarpic perennial, that's a mouthful. What does that actually mean?
It means it's a perennial, so it lives for multiple years, but it only flowers once in its entire life.
Hmm.
Then it dies.
So it puts all of its energy into this one massive reproductive event.
Everything, all its energy, all its reserves, into surviving, growing enormous, and then having one huge effective go at reproduction.
That sounds like a pretty extreme evolutionary trade-off. How long does it wait before it makes that final push?
It can live between 2 and 12 years before it finally accumulates enough energy to flower.
So it could be waiting over a decade.
It could. We often hear about monocarpic plants. The most famous is probably bamboo, which can live for 100 years before mass flowering. Hogweed doesn't get quite that elderly, but that multi-year delay is absolutely key to its resilience. It's the botanical version of slow and steady wins the race.
So it spends years quietly gathering nutrients, building up that huge stem, storing energy in its root. And when it finally does decide to flower, it must be pretty spectacular.
It is. The flowers are white, sometimes pink, and they form this huge umbrella-like structure called an umbel. It can stretch up to 80 centimeters across.
Almost a meter-wide floral display.
Yeah, designed to attract every single pollinator in the area.
And that display is all about mass reproduction.
Precisely. After it seeds, a single plant can release tens of thousands of winged seeds. But when you look at the initial dispersal, it doesn't look that impressive. A study in Scotland showed that between 60% and 90% of those seeds landed very close to the parent plant.
Within 13 meters, I think?
That's right.
So that doesn't sound like a successful conqueror. It sounds clumsy. How did it end up crossing continents?
It takes to the water. Hogweed plants near riverbanks use water currents as their long-distance delivery system. The seeds are surprisingly robust, and they can float for up to 2 days without sinking.
2 days. So they could travel for hundreds of miles down a river system.
And establish new populations far, far from the parent plant. Rivers basically become superhighways for this invader.
That's the movement strategy, but the real persistence, the really stubborn part, seems to be the waiting game.
Absolutely. The seeds can stay viable in the soil for up to 7 years.
7 years.
So even if you clear an area, that seed bank is just sitting there waiting. It means seedlings can repopulate the area long after you think the threat is gone.
That 7-year window is what creates the logistical nightmare for anyone trying to manage this. You can't just clear it and walk away.
No, it transforms eradication from a one-time fight into a war of attrition. You're committing to that area for nearly a decade.
This patience and strategic deployment of seeds, it explains a lot about its invasive history. Where did this thing even come from originally?
It's native to the Caucasus Mountains region. So we're talking Georgia, Azerbaijan, and southern Russia. And in its home habitat, it thrives everywhere. Meadows, forest edges, riverbanks. It doesn't even mind salt spray on the seashore.
That natural adaptability certainly set it up for a global journey. When did it start moving?
Well, it was spread by people who appreciated its massive, imposing stature. It was first brought to the UK's Kew Gardens in 1817 as an ornamental curiosity.
Just to look at.
Exactly, because those massive floral displays are, you have to admit, pretty striking.
And how long did it take to get out?
It had escaped by 1828, so within about a decade, it had breached the gates.
And it was a similar story elsewhere.
Correct. Planted in today's Czech Republic in 1862, invading by 1877. The spread is described as slow but steady, but it has now spread all over Western Europe, Great Britain, Ireland, the US, and Canada.
And in North America, it's been here since at least 1917, probably brought over the same way as an ornamental or maybe accidentally mixed in with other seeds.
It's just a classic example of a plant prized for its beauty becoming a major ecological headache.
Okay, let's go back to that idea of this plant being the final boss. The spread tells us it's incredibly difficult to kill, not just because of the toxic sap, but because of its sheer physiology.
Right.
Why does it survive being repeatedly cut?
That's the core question. Its
Yeah.
stamina is just incredible. Researchers tried to kill it by cutting specimens repeatedly. They cut some plants 4 times a year for 2 full years, and they still didn't die. They were just preventing it from flowering.
So they weren't killing the plant, just delaying its ultimate goal. Why does that repeated attack fail?
Because the hogweed has built up this tremendous reserve of energy in its huge taproot. That root structure can go several feet deep. When you cut the stem, the plant just uses those reserves to produce a new stem, sometimes multiple new stems, to try and reach that one crucial flowering event.
So you're attacking the symptom, not the source.
Exactly. It's like trying to defeat a dragon by clipping its wings. You frustrate it, but you don't actually kill it.
So what is the reliable solution? If repeated chopping doesn't work, what defeats the giant hogweed?
The only reliable method highlighted in the sources is the surgical precision. You have to cut the large taproot 1/2 foot 6 inches down below the soil level,
6 inches below the soil. Why that specific depth?
because that depth ensures you destroy the apical meristem, the specific growing point of the plant. If you just nick the top of the root, it can generate a new growing point. You have to remove its command center
And you have to do that while digging next to a giant sap-covered toxic plant.
while wearing full protective gear, yes. It just highlights why that Herculean name is so fitting. It reflects its real strength and stamina.
That whole combination, the precise, difficult, dangerous removal plus the 7-year seed bank, that is what truly makes it the botanical final boss. So as we wrap up this deep dive, the story of giant hogweed is fascinating because of its contradictions. You have a distant relative of a dinner carrot that demands respect because of its blinding phototoxic sap. You have a delicate-looking flowering plant that achieves the staggering height of a giraffe.
And an invasive conqueror that relies not on speed, but on sheer, stubborn persistence. A lifespan of up to 12 years, and that 7-year seed bank.
If we connect this to the bigger picture, understanding that monoparpic life cycle is absolutely crucial for environmental management, right?
It is. It teaches us that to combat invasive species, we can't just look for immediate results, because the plant strategically uses its energy reserves to withstand attacks, and its seeds can wait for nearly a decade. The eradication plan has to involve years of follow-up. It's a perfect illustration of how successful invaders leverage unique dispersal methods, like water, and just the power of persistence.
And that leads us to a final provocative thought for you to ponder. Given the giant hogweed's incredible ability to survive, being cut 4 times a year for 2 years, and its reliance on a 7-year seed bank for future repopulation, what does this ongoing battle tell us about the long-term, decade-spanning commitment required to control invasive species that succeed not through immediate explosive spread, but through sheer, slow-burn biological persistence?